doing all of the non-graphing stuff first. That should lead us through next week, because it's really only 2 units, or 2 sections. But one of the sections is a big giant pain in the butt. Simplifying and verifying trigonometric identities. It's like algebraic proofs. It looks like that.
No. Is that what was the problem?
Yes.
No. What?
It's taking what's on the left, making it look like what's on the right. Or taking what's on the right, making it look like what's on the left.
I thought that was a problem.
No.
Yeah.
It's all inverse properties and stuff like that. It is trigonometric proof. That's a little bit more complicated than what you'll probably see, but in the realm of how we work with these things, the idea behind trigonometric identities is that it allows you to use your brain. And that's kind of what we do a lot in Algebra 2, especially in this one. We push it a little bit further into the how can you undo stuff and how can you rewrite identities and things like that. It's just a puzzle, is all it is. It's just a puzzle. You'll have what's called simplify, and you'll have what's called verify. That's a verify problem. That means it tells you what it should look like at the end. Whereas a simplify problem, you just kind of keep simplifying until you can't go any further. So some people think one's easier than the other. To be honest with you, it's all kind of the same thing. One, you just know your answer. The other one, you don't. But let's take a look at some of what we're looking at today. Obviously, we're solving trig equations. This is 14.4. It all stems back into this. But we don't need to know that. All we need to know is the sine is cosine is x over r, sine is y over r, and tangent is y over x. And the reciprocal function. We know where certain quadrants, tangent, cosine, sine, and tangent are all positive or negative. We know what quadrants to look for within them. We know how to solve these things through. What we're going to do is we're going to look for the equations. And I think we did an example of this earlier last week where I said, hey, what is 2 cosine of x minus 1 equal to 0? Where we were solving for x. Remember that problem last week? Well, it's the same idea. That's what we're working on today with cosines, sines, tangents, maybe a secant here or there, maybe a cosecant, but it's all basically the same property. You're going to get cosine inverse of something equal to 0. You're solving for your zeros, is what you're doing, okay? So in this equation, where I have 2 cosine of x minus 1 equals 0, think of the cosine of x as your variable. You need to move everything else. What do you move first?
1.
The 1, and then what?
Then you divide by 2.
Good. So everybody in agreement that I'm going to get cosine of x equals 1/2.
Yes.
And then this goes to the idea of how do you undo a cosine? You inverse it. So when you inverse your cosine, you're going to get x equals cosine inverse of 1/2. So where is cosine equal to 1/2? What triangle is that? Oh, there's no calculator.
36 and 90.
What?
What? I did not say that.
They did.
No, I didn't.
So we know it's in a 30, 60, 90. Which angle gives you the 1/2? 60. So we know it has 60 degree, or what's the radian? Okay. I was pleased to see that very few of you guys forgot to write radians and degrees. Some of you guys did, but it was very few.
It said on there.
I know.
Right. Okay.
Yeah, it said to do it, but still people forget. Now, cosine, where else is cosine positive then? Where else is cosine positive?
Second
Well,
and
it's on
third.
the, so second part.
First and third. Fourth quadrant. First and third. Fourth.
Cosine's positive first and fourth. So there's 2 different values within, we're going to start doing this within a revolution, okay? We're going to start looking at it within the full circle. We're going full circle now. Get it? Full circle. Shut. So if this is up 60, this is down 60. So what would this be terminal side? 300. Otherwise known as So you have two separate answers that give you the cosine of 1/2 within a revolution. You're waiting for the other shoe to drop, aren't you? Oh, wait. Baka, 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 baka. Looks like Pac-Man. Let me have my humor on track. You guys don't care. All right, same deal with sine. Gee, it's going to be the same scenario, but what angle is going to have a sine of 1/2? We do the same idea. What other quadrant is sine positive? 2. What's the angle then coming up? Reference angle, come up. 150. Otherwise known as? Okay. What we're doing here is not the general solution. We're looking for all possible solutions within when x is between 0 and 2 pi. Okay. That's what we're looking at. Hi! How are you? We've missed you. Nobody's happy. Melton's happy. That's a crack fire. That was bad too. There it is! You okay?
Look at this.
You've got large hands.
You have large hands.
For a cosine of x plus 1 equals -1. Solve for x. What do you do first?
Subtract 1.
Subtract 1.
Then you divide by 4. And then you just go from there.
There you go from there. Now we're looking for all possible values of x within one revolution. Okay? We're going to do the one revolution stuff today. Then we're going to do what's called general solution Monday. And I'm going to take the homework that we have over the weekend and show you how it easily converts to the other. For some reason, people tend to freak out when you have to do the differences between the two. So between values of x that are between 0, it's greater than or equal to 0, but less than 2 pi. Well, what angle, when you have cosine it's a negative, that means you're going to go into which quadrant?
The second quadrant.
So then we have, it's going to be 30, 60, 90. So which one of these has the cosine? Oops. So that means this is how many degrees? Or 2 pi over 3. Where else is cosine negative then? Third quadrant.
Oh.
Third quadrant, so you just have to drop down your reference angle of 60 degrees. So what's 60 degrees more than 180? 240, wish it was 240. And then what's a pi over 3 more than pi? you go.
I agree with the test. I think that's where I struggled most on the test.
The bouncing?
Well, like not this, like not the degrees, but like knowing what it is in radians.
Okay. Well, if you go, remember, you came up right before the test yesterday saying,
Yeah,
so you're telling me when I see a 4?
Yeah, I know,
it's-
but I knew it was the angle, but I didn't
Yeah.
know how to convert like pi. I knew it was pi over 3, but then when I converted to the second quadrant, I didn't know how to.
Just remember, if you go to the second quadrant, you're going to go up off of 90. So if it's pi over 3 up, it's you subtract it from pi, so it'd be 2 pi over 3. So it's a third less than a whole. If the third's more, it's plus it.
All right, I kind of get it.
And think of it as, instead of just being pi, think of it as 3 pi over 3, or 6 pi over 6, or 4 pi over 4, when you're adding and subtracting the 1/4, the 1/6, or the 1/3.
Okay.
That's the easiest way to do it, is to keep it through that way.
Okay.
Is this horribly frightening so far?
No.
Not yet.
Hey! You guys remember doing trig problems?
Yeah, what kind?
The equations. Want to go show them how to do this one?
Add 1 divided by 30.
Yeah, where is it? Go show them how to do it.
Seal the deal on this one. They don't need me.
All you need is love. Okay. Bye. So apparently you need scouting reports during class.
Yeah. We're supposed to get him during or before school, and he just wasn't in his office.
That jerk. I tell you. Who did you guys wind up with tonight then?
Jacobs.
What do you do first?
You add 1.
Add 1 divided by the root 3. I'm going to show you a little trick. Is there any reason for me to rationalize this?
You don't have to,
I don't have
but I
to,
can.
but you don't need to, because think about it. First of all, what triangle has the root 3?
60,
30, 60, 90. So knowing that tangent is opposite over adjacent. So what angle has the opposite of 1 and the adjacent of root 3?
30.
30. The idea of not rationalizing your stuff when you're solving equations just makes it quicker. That's all. You don't need to rationalize it through on some of these. There's no point. If you did, it's fine. You just gotta go backwards and be like,
Yeah,
okay, it was root 3,
that's
so
very
it's
good.
still the same. It's still the same process, but you still have to think, okay, the root 3 was in the bottom to begin with, and so you know this is going to be at 30 degrees, pi over 6. Where else is tangent positive? Third,
Yeah.
so third quadrant. So when you start at pi over 6 here, and you got to go pi over 6 here, you just add pi over 6 to pi, and you get,
7.
ooh, yes, I'm sorry. Sorry, for some reason I wanted to subtract. Just like earlier today, I was doing my answer key for pre-calc, and I realized that 90 minus 43 is 37.
So you always find answers where both functions positive.
Or both functions are negative. Correct. Because we're looking for all possible solutions within one revolution.
Oh,
Okay, we're looking for everything within 360 degrees or within 2 pi to solve our problem.
so if it was like negative, it was a negative thing, you can do it in
Second and fourth. Yep. If only all of our problems were encompassed within 2pi. From this angle, it looks like you've got brains in the bottom.
I do.
It's pretty cool.
Why don't you just eat the strawberries?
Look at Duck.
That's a cornfield. Ew.
Oh, I'm doing that. Wow. Oh, how would you factor in you guys?
I don't understand.
I'm not gonna lie. I don't know where to go.
There's a lot of factors. Wait till you guys see what the stuff we get to do.
Do the X, do the signed X's.
Alright, so you gotta subtract the sign of X,
Doesn't that cancel that out?
which cancels out, so you get
So then you just have 10 squared of
X
X
equals
I think
0.
it's funny.
Oh, yeah, so it's squared of X. So,
I'm back. It's in bold.
you do square root of X.
I definitely put myself in a fan that I can handle all screen. It doesn't go yourself. It gives me
Hey, let's. Yeah, I don't want to get you guys to the factoring yet. I don't want to do factoring yet. We'll wait on the factoring.
Oh, we were.
There's just a couple other parts to this I want to look at before we do that.
I thought I was getting somewhere.
Yeah. I'll bring the factoring in with the, when we do the, what's called the general solution. Hey, section 14.4 is almost the end of the book, so we're almost done.
But didn't we bounce around?
I'm sure.
The physics is out. I mean, my brain is.
He switches on like things that he shouldn't switch on. He takes my man, and I'm like, what are you doing? Whenever he's the forward, he takes my man.
He switched me.
And I don't know how to do it.
I'm not gonna do that factoring one, no. I'm gonna wait on the factoring until next week. I'm gonna keep this with non-factoring to start with. So think of this problem. You have 5 cosine of x minus root 3 equals 3 cosine of x. Think of this as the variables on both sides of the equation. Whenever you had variables on both sides of the equation, what did you do? Move them. You picked on the little guy. Which one of those is going to be easier to move, 5 or 3? So if I subtract 3 cosine x, I don't move the root 3 over at the same time. I get 2 cosine x equals root 3. Now what? Divide by 2. Very good. So the inverse cosine of root 3 over 2. What triangle has the root 3s and 2s?
390.
It's nice that these triangles keep showing up, isn't it?
I'm tired of
We
trying to
may or may not have mentioned the fact that you need to know those at some point in time in your lives, right?
You guys never
I think I did.
Never mentioned it, ever. What angle gives you the root 3 over 2?
30.
30, so pi over 6. So at pi over 6, where else is cosine positive?
In the fourth quadrant.
Fourth quadrant, so what's that angle then? 330 or?
No.
So,
Yes, sir.
I have a question. I'm not trying to be a jerk here. I actually want to know.
No, that's fine.
Like, what profession uses like these equations and all this?
I don't know. Engineering.
I kind of want to know because like,
It's a lot. No, seriously, and it's a great question. Think about when you guys first learned equations. You learned back in probably first grade. You did this. right? You guys did that stuff in first grade, and then eventually it started going, it progressed into this, then it progressed into this. You know, you started moving stuff around, then all of a sudden you had this. Well, as you get further along in math, the equations, the process, you know, 1 step, 2 step, that doesn't change, but the complexity of the equation changes. So as you went through it last year in geometry, you solved equations with very basic SOHCAHTOA stuff, or you did some proofs and things. You did a lot of areas, formulas, volume formulas. As you get into trig, you start to deal with more of the trigonometry equations. It's not that if there's a specific thing or field that's only going to be using trig equations. It's just the idea that it's just another equation. It's just another solve for x, which is math, really. So, but a lot of times, things that use trig a lot are you know, engineering. It's a lot of engineering. Anything, it's a lot of sciences still use trig. Well, I don't know science much. I know, like chemistry, they use a lot of logarithms, exponential function things, a lot of those properties. Any of the other physical sciences, there's a lot of trigonometry. Physics is all trig.
Yeah.
You know, things like that. You can do a whole bunch of stuff. Hi, Kobe. We've missed you.
Have you?
Not really. Just trying to be nice. Here you go, sir. 3 plus box is 5. What is it, Kobe? Yay!
Fancy it.
Don't let the door hit you on the way out.
It's all, so,
Hey, on that very bottom left, is it scratched out and it has something written above it? Like the 180 theta 270?
is that right?
Yeah.
It looks like LOL, but it's not.
Got it.
If you can't have any fun with your job, what's the point of doing it, right?
Facts. Money. That's a fact right there.
All right, so let's do these. It doesn't matter.
I know he's not giving Facts. I don't know what to do.
Let's go 19 through 24. Yeah, this is 19 through 24. This is 8:59.
No one's taking them. No. I tried yesterday. It did not work. So you tell me what to do. I hate it. I'm gonna stop.
If you want to give your answers in both radians and degrees, that's perfectly fine. Usually towards the end of this, by next week, I'll probably stop using degrees, just so you guys know. Yeah. Let's just do those 6 for now, and then I know the instructions on the problems themselves talk about what's called a general solution. I'm not going to worry about what that looks like quite yet. I just want you to solve the equation. So those 6 probably won't take you 15 minutes, really. You should be able to get this done before you get out of here. And then on Monday, we'll hit this stuff a little bit harder and then talk about the factoring and how some of the other things can interplay with Oakley Dokley. I'll throw this up here too for you. You can't see. All right, 21 has a co-function identity to it. When you do 21, I gotta show you the rule here.
Those are only problems we do. That's our homework, right?
Yeah.
Just 6 problems. Sophomore, never mind.
I haven't heard of any.
So on 21, there's what you call a co-function identity. And when you write this out, this is the same thing as sine of x equals -1 sine of x plus 1. That's what that means. We'll talk about those identities later on next week. But the rest of them should be all right, even though you have that sine squared. One little trick. How do you undo squaring? When you square root over an equal sign, what do you have to have? Very good.
Wait, what'd you
Yeah.
say?
Plus minus. Okay. Okay. That's a little hint for 23 and 24. The rest of them should be all right.